Hey guys, let's look at this number 11, container with the most water. So we are given non-negative integers a to n, which each represent a point at coordinate I. So which means the height of the board. So we find the two lines which together with the x-axis forms a container. So container like this, such that the container contains the most water. You may not slant the container n, and n is like this too. Slant. What is slant? God, I don't know what slant means. Oh, so it's vertical. Slant means make it not vertical. So let's do it with brute force. Brute force. Which means we will calculate all the container. So with absolute O and square. I think this doesn't mean to write, right? Doesn't need to be. It's very straightforward. This is the four. Well. Let's just. Let's say. Yeah, let's just write it down to practice our coding skills. So for let's I equals 0. Height is a integer array. So then this one, nice one. Equals max. We will calculate the water. First, we need to say the distance j minus I times math mean height I height j. Okay, so this should be working, right? Yeah, that's right. But it's definitely not gonna be the fast because it's quadratic. I think the word should be quadratic. Yeah, it's n to square. So let's make it better. So how I would think this problem is that the container needs two board, right? Let's just suppose that the container with the farthest width, like the first one and the last one. So they are creating this container, right? So now if I need to pull down the border, let's say, so this just think about this graph, because the first one is shorter than the last one. I can safely put down this one, but I cannot pull down this one, right? Remove this one. Why? Because it is smaller than this one. Anyone would be bigger than it, would be some border within it, but height taller than the smallest one. So I can safely remove this one, and the audio containers would not be starting with this one if there is a bigger one, right? You will be starting with another one. Yeah, but why we cannot remove this one? Because if I remove this one, the container here might be bigger than the original container. Why? Because there might be something larger, taller in the middle, which create a bigger container with this one, which means that for a border like this, if we want to insert a new border uh, in the middle, it will possibly only create a better, larger container with a taller one, not with the smallest one. Like I insert this red one, this container may be possibly bigger than the original container here, but the container here could not be bigger because this will be the smallest among these three borders. So actually we can have two pointers, one from the beginning and one from the rear, and then we calculate the container and remove the smallest one and do this back and forth. And finally, when the two pointers met, we end it, and this will actually create so we choose two pointers, and actually the time will be better because every border will actually every time we will remove a border, so the time will be linear. Let's write it down. Okay, so the result is the same. So the result we just keep it in the max. So let I equals 0. Let j equals height minus 1. So while height at I is smaller than j, while there's space. Okay. First, we calculated the water, which means this max is max, this and the min. Yeah, this is the same. Yeah, and then we try to move the pointers. Two cursor. I don't know the formal name. Maybe two cursors. Two cursors. Left right cursors. Yeah. Anyway, you know what I mean. If height I is smaller than height j, if height I is smaller than height j, we just height I plus 1. In the other way, j minus 1. So that's done. Try see the result. What? It doesn't work. Wait a minute. 0 mass main height I, height j. Oh god, length. Yet it's passed. Cool. Actually, I could actually improve one because improve the move here because if for the next border, if it's smaller than next one, like from here to here, I don't need to calculate it. I don't need to calculate the container because it's definitely gonna have less water. So I will just move it. Move I. Okay. Move I to the next bigger border. So while, because we already moved it one further, so while height, while okay, while height I plus 1 is smaller than height I. Well, let's say let k equals I, while k while k smaller than is smaller, and a plus equals 1, and then we move it I equals, so k will stop when it's bigger, so we set it to k, and j will be the same. Let's say k equals j minus 1, while k is smaller than j, k minus 1, so j equals k. This should generate the same result but faster. We just remove those, we reduce the calculation, so, but it doesn't matter, it doesn't change that much, I think. Yeah, it's just that's the but it's definitely better. Okay, so that's all for these questions. See you next time.